Hi, welcome to the channel. So today we're going to get started working with Pandas and Matplotlib. The idea is to work with some online retail dataset. Basically, this has transactional data of an online retail store. I think it's a really good way to learn Pandas and Matplotlib. So yeah, let's get started. This is more or less the plan for today. Reading the data, then doing some data visualization, some statistics, and finally, we'll be doing some more intermediate level data wrangling with Pandas. The dataset, you can download it from here. Let's import these packages first. You might need to first install this OpenPyXL library in order to read the Excel file that we have here. I just downloaded it and put it in a data folder, so that's why I can read it. But you can actually just read it directly from the internet. Okay, so it took a few seconds to read, not a big deal. So this is how the first observations look like. We have some invoice ID, stock code, which is probably the item ID, description, like the description, the text description, then the quantity, so the number of units that were sold, invoice date, so the date, the timestamp actually it was sold, so we have hour and minutes also. The price it was sold, then the customer ID and the country. So I think it's a really realistic data set that you can find in any retail. So this has 525,000 observations and 8 columns, so 500,000, not that small. This gives us some information of the memory it uses, the data types. I think the data types are pretty okay in general. And we can see that the invoice date got converted to datetime automatically. So I didn't have to do anything and it was parsed correctly. So that's really great. We don't even have to bother converting this to a timestamp. So, okay, this is mainly the description. I just mentioned it. So I'm just leaving it here as a reference. So the first thing I would like to do is to convert these columns to something more consistent. And I generally prefer to use lowercase columns because I can use them with the dot syntax. So basically what I did is just grab this list and I modify the names a little bit. So here are the new names. What I like is that you can just do, for example, if I want to select one column, I can do df dot, let's say, quantity, and I don't need to do all this thing to select the column. And when we have space in between the column name, we can't do that. So for example, here I can just call customer ID, but I wouldn't be able to do it if it would be called like this, right? I think this syntax is more readable and generally it's used a lot. The first step, okay, let's get the kind of general sense of the date. How many invoices are there? This is what tells us that. So I do df.invoiceid.unique and I get the number of invoices, of unique invoices. So I can do the same for the items. So there are less than 5,000 items. Description, seems like description and item are kind of the same thing, more or less. Few are missing there, but looks very similar. Customer ID, so 4,300 customers. And here I can print the start and end date of the dataset. So it starts in 2009, December, and it ends in December 2010. So that gives me some idea of the dataset, right? And you could do other simple statistics like take the average of the quantity, the average of the price, compute the total sales and take that average. And this is very helpful in order to get started with the dataset that you know nothing about. And here I have the number of countries. Okay, so moving forward. So here I'm computing the total sales column and basically quantity times price. So that gives me an idea of the income that the company generated with each sale. And this is a little bit more informative than just the quantity. So then one thing that I do a lot, if you've seen one of my videos, you've probably seen this. So here I'm selecting the sales column, df.sales, and then I'm passing .quantile. And what this does is computes the percentile at the values that I pass. And here I'm passing 0, 0.25, 0.5, and 0.75, which are very commonly used. So I'll just run this and we'll see. Let's understand what this gives us. So what this means is that, okay, this is the minimum value, right? So we have a negative value for sales. So that means that's probably the refunds. And the maximum value is 1. So these two, I mean, they're not super informative. They just give us some information. But I think what is more interesting to me is this part. So here, the 0.5 percentile is the median. So we can see that the median sales is 9.95. And that gives us some idea of the business. So the business in general, if I have to pick a value that represents the center of the distribution, is around $10. And what's also interesting is the values, the range between these two values. What this means is the 50% of the data that's in the middle of the distribution, so between the 0.25th percentile and the 0.75th percentile, is between 3.75 and 1770. So that gives us a range of, okay, what's normal in a way, or what we can expect from a sale. Okay, around $4 and $18. And I like this calculation a lot. I think it's very descriptive. And I mean, if you compare this to a histogram, right, you can do this. I mean, really, what information does this give you? Nothing. And if you do a Boxplot and look at this, I mean, what does this give you as information? It doesn't tell you anything because you can't even see the median. So just for reference, these values, they are the ones that make the box in the Boxplot. So this is like the lower end of the Boxplot. This is the higher end of the box in the Boxplot. In these cases, when you're looking at the data, this is really, really useful. So there's also information in the data description that says that invoices that start with a C have a refund, and we can verify that here. So if I filter by negative sales, we get invoices with a C here. Okay, so this is the kind of first analysis I would do. Just take a quick look at the data and try to make some simple statistic. Next, we can take a look at the demand curve. What this means is plotting quantity and price. I mean, this is a very typical relationship, right? That this comes from economics, that there's a negative relation between quantity and price. And here I'm plotting it with log axis. So both axes are in log scale. Let me show you how I'm doing this plot. So first, here I'm doing this query. That is the price, lower than 10,000, the price larger than 0, and the quantity larger than 0. So I'm filtering out the negative values, right? And this is the plot call that I'm putting quantity and price in the X and Y axis using kind-scatter, and alpha 0.1 helps avoid overplotting. So if I would remove the log plot, this is what we would get. I mean, not very informative. So, and this is very typical in, when the data has this kind of situation, you need to plot it with logarithm in the scales. And this still tells us that the distribution is negative mainly, not a lot more than that. And yeah, here I wrote down some ideas on how you can read this axis label. So 1 is 10. So whatever that's between here is less than 10. And whatever is larger here it grows by powers of 2. So this is 100, 1,000, 10,000. So that's more or less how you can read the plot. Okay, one more simple and useful calculation we can do is compute the daily sales. So basically here we're taking our data frame, we're grouping by date, and then we're selecting the sales column. And as a computation, we're taking the sum. So this is one method of doing this that I'm calling it compact method. And I mean, for simple things, this is totally okay. It's not wrong. It's just a one-liner. In some cases, when you have a more complex problem you're working with, you can use the parentheses around this calculation and write each line, each operation in a different line. So here I'm doing the group by. Here I'm selecting the column I want to take the sum, and this is the function I'm applying. And this is the same result that we get here. And really, once I have it in this format, I can just grab that series object and do dot plot. So let me show you. This is a series. By calling type, I print the data type of this object, and it's a series. So I can use the dot plot method, just passing a title, and this is using matplotlib internally, but I mean, it's really simple to make this plot. That's really one of the advantages of using the pandas.plot method. I try to use it whenever I can. In some cases, the plots are a little bit more difficult, but for simple things, I try to use it. Okay, so this doesn't tell us a lot because we have all the refunds happening. So maybe we just need to aggregate the data on a different time frequency. And this is what I'm doing here. I'm aggregating it at the weekly level. So first plotted. Here I'm just grabbing the sales data that I had. I'm resampling by week. And think of the resampling as a kind of group by. And then I'm just calling sum. So it's aggregating the information that we have for every day at so we get one observation for each week. Then I'm calling plot. And this again, you could break it down and do it in one line for each operation. And you can also pass in monthly here, which is not very interesting, but that's really kind of powerful, really powerful data transformation you can make. And again, I'm also using dot plot. That's the pandas.plot method. Let's continue. So here I have an example on how you can do some statistics at the country level. So this is a little bit more complex because I'm doing multiple computations here. So I'm first doing a group by on country, selecting sales, and then I'm calling .ag, and this basically lets me apply multiple functions in one call. So finally, I'm doing a reset index, then sorting by sum. So let me show you how this looks here. Just going to run it above. So if I wouldn't do the reset index, I would get this column as an index. But basically, we have a column for each of the functions that we're applying. And then if I sort it, I can select one of these functions that I apply, and I'm sorted by sum. So this is actually the sum of sales, right? So the column that we're working in is sales. And so these are the top countries in terms of global sales: UK, Netherlands. So this is probably from Europe. And if I look at the countries where the least sales were done, I can do country.tail. yeah, we can see the statistics of these countries. So this is the mean, the total, and here's the mean and median. It seems that most of the sales are concentrated in the top countries. And yeah, there's a lot of things you could do with this in terms of data analysis. I think just wanted to do some group by operations and maybe show some results, but you could do a lot more with this. Finally, you can grab this data frame that we created, sort it by some other variable, and then plot it. So basically, I'm plotting the country on the x-axis and the variable on the y-axis. And I'm using a bar chart in this case. Basically, this is how it looks. So if I sort by mean, this is the result. I mean, I could sort by sum. And yeah, sum here. And we get a very different result. And finally, we have a little bit more complicated operation here. So I want to take a look at a little bit the item level, sales, quantity, and price. So let's take a look at the item level data. So here I'm showing a few rows. I can also redo this calculation of the quartiles of sales. And yeah, we get the same result as before. Let's go to this aggregation. So here I'm grouping by item ID. I'm selecting sales, quantity, and price. So 3 columns. And then I'm calling ag.ag, and I'm passing two functions, mean and median, right? So let's see how this looks like. And what happens here is this a little bit different structure in Pandas. So we have an index on the left here, but here we have a hierarchy. We have sales, and then we have these 2 calculations, quantity, and then these 2 functions, and the same for price. So this tends to be problematic for most people, and I think it's yeah, when you get to this situation, you start looking for answers, and yeah, it's not simple. So now there's a way that you can name these columns as you want, but let's take a look at this situation that's very common. So if I print the columns, so instead of getting just the column name, I get this 2-level structure, right? So we have sales and mean, sales and median. So I would prefer that this would be just concatenated in one column. So basically, this is how you can do it. So you simply loop through this element, 4 calls in item columns, and then you join the text with the underscore. So this is how you go from this situation to this situation. Here I'm using a list comprehension. And then I'm just assigning this to the data frame columns. So run this and we get this data frame, but now the columns, they just have 1 level. And I find this a lot simpler to work with. So now I have here the analysis of the distribution, but at the item level. So we have these averages of sales, averages of the median and quantity, etc. I want to compute some statistics on these averages. So I grab this data frame item, and I select sales mean and quantity mean. And I compute these statistics. What this is telling me is that at the item level, what is the average mean? What is the average mean and the quantity mean? So yeah, this shows me the distribution of what each item has as average or quantity, right? And you could do the same thing using decimals. So you can just create these breaks here and apply it to quantile. So, and this shows the distribution of the item means. It's a little bit complex, I think, to understand, but so let's get back to this data set. So here we have one observation for each item, and each observation is an average. So we're basically summarizing the items. And what I'm doing here is looking at the distribution of the averages at the item level. So this is the median of the sales at the item level, and this is the median of the quantities at the item level. Okay, and that's it for today. The idea is to continue working on this dataset and perhaps do a more interesting analysis. But this, I think it's an interesting way to learn some of the basics of Pandas and the most common operations, that at least the ones I use the most. Okay, I hope you enjoyed the video. Please subscribe and like it.